Modern.
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 We're prepping for a voyage.
Modern.
The force of an old-fashioned equals whiskey mass times bitter's acceleration.
Why don't you make that a double?
Modern bar cart.
What's shaking, drinks fans? Happy New Year and welcome to episode 308 of the Modern Bar Cart podcast. I'm your host, Eric Kozlik. Thanks for joining me to kick off 2026 with this audio essay episode where I select one very specific layer from the vast matrix that is spirits and cocktails and try to give you a glimpse of how precisely it works. Now, a little warning here, this audio essay occasionally wanders into rant territory, and that's because I've chosen to dig into a topic, a poorly posed question really, that has bothered me for years. At first, I couldn't quite put my finger on why it rubbed me the wrong way, but over time, I've become really clear on why that is, and I'm here to break it down for you. The question is this: how much of the flavor in a whiskey comes from the barrel? Seems innocent enough, right? Seems like something distillers and coopers and spirits experts and bartenders might be able to answer if they all put their heads together. But when you approach this question from different evidence and common sense backed angles, you quickly realize that the universe of flavor science and perception is stranger and more complicated than most people think. Before we dive in, I do want to apologize in advance to anybody I alienate with this. I'm very intentionally not going to name any individuals or link to any blogs or social media posts where people spread the kind of misinformation I'm trying to correct in this episode. It's a really common topic, and I know that I have friends who have gone on the record with their opinion. But my goal isn't so much to point fingers as it is to correct the pervasive whiskey barrel math that's treated as gospel by producers and consumers alike, but that's unfortunately built on a foundation of bullshit. Sammy, let's give the old bleeper button a quick test because there might be one or two F-bombs that get dropped over the course of this. Does it work? Good. With that, please enjoy this lighthearted little romp through the world of bourbon barrel science, flavor phenomenology, and behavioral economics. The first thing to say about this question, how much of a whiskey's flavor comes from the barrel, is that it gets answered way more than it gets asked. Or, put a little differently, if a distiller or a cooperage or a whiskey expert asks this question, it's mostly as an excuse to give you their answer. And why is that? Well, it's because normal people don't look at a glass of whiskey and think, oh, there's just no way I can enjoy this until I know exactly how much of the flavor comes from the barrel. I like to call situations like these infomercial moments. It's the part of the commercial where they show you a black and white cutscene of a person comically failing to do a very basic everyday task that most people can manage just fine. And you'll notice they always follow this with a flashy transition wipe back to a full color feature of whatever miracle gadget they're selling to solve the problem they've just invented in the cutscene. So the sheer fact that so many experts keep answering a question about barrel-aged spirits that most normal consumers aren't losing sleep over should alert you to the fact that something fishy might be going on here, and that at the end of the day, it might be related to money. We'll return to this at the end of the episode, but before we do, I'd like to run a few thought experiments designed to teach us about the dangers of trying to quantify flavor. One very obvious way of answering the whiskey barrel flavor question is to say, if only there were a machine that could analyze a sample of whiskey and tell us precisely what percentage of the compounds in the liquid could be attributed to the barrel, as opposed to other steps of the production process like fermentation and mash bill, then surely we could just run the numbers and come up with a reliable range of percentages that are reasonably consistent across different whiskey categories. Well, lucky for us, there is such a device, and it's called a gas chromatograph mass spectrometer, or GCMS. How do these things work? Well, First, the gas chromatograph separates volatile compounds from a vaporized sample as they pass through a column. And as they go through, they're carried along by an inert gas like helium or nitrogen. As this all happens, some of the smaller, lighter compounds will pass through quickly, and others, the bigger, more complicated, clunkier ones, they take a bit longer. So at the end of the process, you have compounds that are separated and grouped together by their relative weight and size. Then, as the compounds exit the column, they enter the mass spectrometer, where they're ionized, which means the machine essentially manipulates the charge of the flavor molecules. This ionization pattern allows the device to identify each compound and calculate its relative abundance within the sample. I know it sounds complicated, and it is, but the TLDR on the old GCMS is the GC, gas chromatograph, separates the different flavor compounds, and the MS, mass spectrometer, identifies and quantifies them. The report that the machine spits out looks like a line graph with a bunch of peaks on it, with each peak representing its own compound and the height of the peak showing how much of that compound is present in a parts per million context. If you're a Scotch fan, you may be familiar with the abbreviation ppm, which stands for phenolic parts per million, which has become a popular way of quantifying how smoky a whiskey will be from the influence of phenols from peat. But really, you can measure hundreds, probably thousands of different flavor compounds using a GCMS. Now, I've taken the time to walk you through the basics of how a GCMS works because it's a very direct sort of one-to-one way of answering the question, how much of compound Y is present in sample X? Because of this, there's plenty of scholarly studies on the internet, nice recent ones in fact, that have used GCMS analysis to compare various unaged and aged whiskey samples. And while these papers go into a lot of detail about what compounds they detect in the samples, they're much more cautious about attributing the compounds to any one step of the production process or making claims about how they relate to flavor. They'll say X was present in Y but not in Z, or they'll acknowledge that barrel aging contributes significant flavor to a spirit, but they won't make any attempt to quantify what they mean by that. And that's smart because it's one thing to measure the flavor compounds present in a sample, but it's another thing entirely to make claims about how we actually experience those chemicals as flavor. To illustrate this, I'd like to contrast the machine measurement process I've just described with the way that the human body processes flavor. One key thing this will show is how radically our nervous system anatomy differs from machine sensors. And I think this is valuable because there's a distinct tendency within the spirits industry to treat the palates of expert blenders and tasters as fleshy versions of a GCMS. And I want you to understand exactly why that kind of thinking can get us into some trouble. Now, I'm going to do an immediate 180 here. Looking at the human body, I do have to admit that the first phase of flavor processing, only the first phase, I promise, does produce an output remarkably similar to the GCMS report I just described. And it's similar in that, again, it's a pretty one-to-one rendering of a flavor stimulus. Since we're talking about volatile flavor compounds, which is what a GCMS measures, we'll look specifically at the olfactory system here, the sense of smell. That's the best comparison. And the thing that most people know is that when an aroma compound enters the nose, it will activate the aroma receptors located on our olfactory epithelium, sort of like the taste buds of the nose. But what happens next? What happens after that? Well, activated receptors send an electrical nerve impulse to a structure at the bottom front of your brain called the olfactory bulb, which aggregates the activation pattern of receptors and represents them in much the same way that a GCMS report will show peaks of certain flavor compounds. In both cases, what's being rendered is a depiction of what's present and how much of it. Instead of thinking of the olfactory bulb as generating a line graph like the GCMS, though, it's more accurate to think of it like a pointillist painting. Each dot on this pointillist painting is a cell in the olfactory bulb called a glomerulus, and each glomerulus aggregates activation data from thousands of individual receptors in the nose. The result is sort of an electrical mosaic image of what's happening with the olfactory receptors. But it's a mosaic with a direct connection to reality. Either a receptor is firing, meaning that there's an aroma molecule activating it, or it's not. You can sort of think of this firing versus not firing like the zeros and ones in binary computer code. But where the GCMS rests its case, the human flavor perception system keeps going. Here, it's important to note that this activation pattern in the olfactory bulb is not what we experience as flavor, because from the olfactory bulb, these nerve data are shipped off to the olfactory cortex, where a really important thing happens. It loses its one-to-one tie with reality in that it no longer is a perfect reflection of which smell receptors are firing and which aren't. This happens through a pattern of nerve inhibition and excitation whereby some features are emphasized and some are de-emphasized in order to achieve better resolution. You can think of this like stepping back from a pointless painting and watching clear-cut shapes emerging from the chaos of dots on the canvas. In so doing, you lose your contact with each individual dot, but you come in contact with a larger picture you wouldn't otherwise see if you had never stepped back and allowed some of the fuzzy edges to fall away. This transforms the two-dimensional smell image, that mosaic that was registered in the olfactory bulb, into something that acts more like a three-dimensional flavor object that activates and is acted upon by many different circuits in the olfactory cortex and beyond. So to recap, the stimulus has been transformed from zeros and ones in the olfactory bulb into a comprehensible, manipulatable aroma code in the olfactory cortex. At this point, it's sent along to the orbitofrontal cortex, the very front part of the brain, the most human part, you might say, to be integrated with our very highest cognitive processes: language, emotion, and memory. The orbitofrontal cortex is where all of the Proustian aspects of aroma and flavor emerge. It's where we become able to put a name to an aroma quality, and it's also where we decide if what we're perceiving is pleasant or unpleasant. All of which is influenced by our memories of sensory experiences in the past and modified in real time by incoming information from our other senses like sight and touch. Here's the upshot. A GCMS report is only separated from reality by 1 degree of abstraction: the act of transforming a collection of real flavor compounds in a tube into a line graph printout. The felt human experience of flavor, on the other hand, is separated from reality by at least 4 degrees of abstraction. Random inputs from our smell receptors are represented as data in the olfactory bulb with its two-dimensional activation pattern that looks like that mosaic we were talking about. These data then become structured, content-addressable information in the olfactory cortex thanks to a great deal of excitation and inhibition that enhance resolution. That information becomes meaning in the orbitofrontal cortex as it gets processed by language, emotion, and memory circuits. And finally, with enough repeated exposure to certain stimuli over time, the human sensory system develops a sort of resonance with flavors based on a very complicated and subtle system of overlapping memories and preferences that are completely unique to the individual person and non-translatable to anybody else in the world. Let me say that again. It takes 4 degrees of abstraction from reality in order to achieve a working model of what humans experience as flavor. Reality becomes data, data become information, information becomes meaning, and meaning gradually evolves into a personal resonance with the flavors we perceive. I've gone through all this trouble of painstakingly laying out the differences between a human palate and a machine rendering of flavor because I think that anyone looking for ironclad answers to the whiskey barrel question in a GCMS report is barking up the wrong tree. And here's the thing, as much as I enjoyed putting together that human versus machine comparison we just worked through, there's an even simpler way to demonstrate why a GCMS report isn't where the buck stops when it comes to flavor. Let's say you've got a barrel of cask strength bourbon. You empty the barrel and you split the liquid 50-50 into 2 different vessels for proofing. Using the exact same reverse osmosis, completely neutral water, you proof down half of the sample all at once. You just dump the water in all in one go. Let's say you proof it down to 45% ABV, and you proof down the other sample much more slowly, say over the course of a week or more. Any good blender will tell you that these two samples of whiskey are going to taste different, even though they're both identical in terms of the influence of the barrel. This is kind of like a twin study showing the impact of nature versus nurture in the whiskey world. If you ran these two samples through a GCMS after proofing, I don't know if the reports would be identical, but my suspicion is they'd be pretty darn close, whereas the flavor differences between the two samples would be eerily different when you taste them. It's a simple, elegant way of demonstrating that a machine can tell you facts about the world, but only you can experience it. So I've explained at the level of biology and neuroscience why it's pointless to conflate the mere presence of chemical compounds with flavor experience. I've explained it at the level of an actual sensory experiment you can run, and that many have run in a distillery setting. Now let me explain it at the level of common sense. If you ever happen to be chatting with a pilot at an airport, you wouldn't point to their plane and say, "What's that, about 60-70% aluminum?" As if something about the plane's structural composition is going to have a direct impact on your relationship to it or the price of your airline ticket. As if you're going to enjoy your flight more because you understand the aluminum to plastic ratio of the plane's composition. Of course not, because that would be absurd. Now, let's say you're utterly unconvinced by anything I've said so far. Let's say you're thinking, "Eric, you're completely missing the point here. People aren't trying to add up different compounds on a GCMS report. They're merely trying to express how much of the flavor on their palates seems to be coming from the barrel, as opposed to other production steps like fermentation and distillation. They're just using the percentages as a metaphor for what they're experiencing on their palate." To that, I would say, okay, let's run a few scenarios. And here I'm going to hang out in the bourbon world because we all know that the cask has a massive influence because it legally has to be a brand new one and done charred oak barrel. So it's very straightforward to talk about barrel stuff with bourbon. So let's say we've got a bourbon. Let's say it's a nice, robust, straight bourbon whiskey aged at least 2 years and bottled at 45% ABV with notes of vanilla, caramel, and baking spice with some fruit and cereal grain notes in there. And let's say that experts agree that the barrel seems to account for about 70% of the notes perceived on the palate, with the mash bill providing another 20% and the fermentation esters adding the remaining 10%. This is a pretty standard account that you might come across on a distillery tour or on some online bourbon forum. So again, for the sake of argument, 70% barrel, 20% mash bill, 10% fermentation. Let me ask you this. What happens when we cask finish this product in an Oloroso sherry butt for 6 months? That obviously adds additional flavor. How do we quantify that? Do we want to say it makes the spirit 20% more flavorful? Maybe we run the sample through a GCMS and it shows a 20% increase in new flavor compounds. Obviously, we can't have a spirit with 120% flavor, so we clearly need to modify our numbers, get them back in touch with reality. Since 100% is actually 83% of 120, we need to multiply all of our original flavor percentages by 0.83 to get back on track now that it's sat in that sherry butt. And when we do that, we can definitively say that our original straight bourbon whiskey finished for 6 months in an Oloroso sherry cask would now owe about 58.3% of its flavor to the bourbon barrel, 16.7% to the mash bill, another 16.7% to that Oloroso sherry cask, and now only 8.3% to the fermentation. But what if instead of 6 months, it was finished for 12 months in that Oloroso sherry cask? And what if there was a lot of big temperature swings? And what if halfway through the cask was moved from the bottom of the rickhouse to the top? And what if during that process a really tiny stave leak occurred, leading to excess oxidation? What are the flavor percentages now? At this point, I expect you see what I'm driving at. But wait, we haven't considered what happens if I decide I'm going to launch a Cristalino bourbon where I take the exact same straight bourbon whiskey I made before, then run it through a charcoal filter so it's clear. Now, obviously that filter's going to strip more than just color from the product. A lot of flavor's going to get taken away as well. So does that mean we now have a product that's only, say, 50% as flavorful as the original? Does that mean our original 70-20-10 split is now 35% barrel flavor, 10% mash bill flavor, and 5% fermentation flavor? No, that would be insane. You can't have a spirit with just 50% flavor, and clearly the large flavor compounds stripped by the filter disproportionately represent those that would have been contributed by the barrel. So now we need to convene a sensory panel to determine not only what the new flavor percentages should be, but also how strongly the color of the spirit is associated with barrel flavors in the minds of consumers, such that they're actively missing some barrel notes that are still present due to the fact that the product is clear instead of brown. Is it now abundantly clear how this kind of math is? And I do think it bears emphasizing that I'm not making any bad faith moves or assumptions in these scenarios. I'm simply pointing out how immediately and radically these ham-fisted percentage attributions break down as soon as you try and do something that most spirits brands do. Either add flavor by any number of methods or take away flavor by either chill or charcoal filtration. The math is completely idiotic, and I don't understand why people are so obsessed with using it as any objective measure of what's happening when a spirit hits someone's palate. My problem with trying to slap a percentage on something as complicated as barrel flavor dynamics isn't that it attempts to shine light into an area that I think should just remain murky. I think it's great to talk about flavor, and I think an incredible amount of progress can be made if people slowly and carefully discuss their personal flavor experiences around a table. That's what we do at Spirits Judgings all the time. And I'm either administrating or serving as a judge at 2 of those in the next 3 months. So I'm very bullish on productive conversations about flavor. Love them to death. But what I think is particularly dangerous is the way that numbers and percentages have a way of crystallizing things in our minds and informing our values and expectations. When you say that barrels are responsible for 50 to 80% of the flavor in a spirit, you're contributing to what philosophers of science call the theory-ladenness of observation, which is just a fancy way of saying what most of us call confirmation bias. In other words, if you go into a tasting assuming that a barrel is responsible for 50 to 80% of the flavor in your glass, that's what you're going to find. I could write pages and pages about why this is bad for the spirits world, but it all boils down to this. If you want diversity on the shelves and behind the bar, and spirits categories that aren't all developing the same kinds of products because they think all consumers want the same thing, you should be naturally worried about assigning numerical value to barrel flavors. Listen, I get it. Slapping a percentage on something makes you feel like you've got a grasp on it. It's a mental shorthand that allows you to dedicate your conscious processing to other tasks when you're tasting a spirit. But people, myself included, are painfully bad at math, especially when they're distracted, which means that it can be very tempting to start thinking that if a barrel contributes 50 to 80% of the flavor to a whiskey, then a whiskey that's been in a barrel for 4 years is going to be 50 to 80% more flavorful than one that's only been in a barrel for 2 years, or that a spirit aged in a 53-gallon barrel is 50 to 80% better than one aged in a 30-gallon barrel. And I can tell you that when American oak cooperages are consolidating at the same rate as cell phone companies and motion picture networks, and the majority of the barrels produced there get shipped straight to massive distilleries owned by a handful of international spirits conglomerates, it's not the executives who are reviewing profit and loss reports who are going to take time out of their busy days to correct those mistaken assumptions, because they're making money off of them. Remember? I told you we'd get back here to that infomercial moment I described at the beginning of the episode. And since we are, let me remind you where you fit in. You're watching the infomercial. You're the target audience. And the problem they invented for you is that you need to know precisely, with apparently an error rate of 30%, how much flavor in a whiskey comes from the barrel. And you've got two options. You can think about all the reasons I've just supplied that explain how impossible it is to calculate your way into human flavor perception, and how stupid barrel flavor math gets as soon as you press on it just a little, and how leaning on big sloppy percentages can cause us to make lazy assumptions that limit diversity and innovation in our industry, and you can turn off the TV and walk away. Or you can pick up that phone and dial that number and buy what they're selling, and they'll send you a framed limited edition made in the USA commemorative print that says between 50 and 80%, and you can hang it right above your liquor cabinet so that you remember to tell your friends when they come over to sample from your collection and bask in your whiskey knowledge. But wait, if you call in the next 10 minutes, they'll even throw in a free set of premium whiskey stones so that your bourbon doesn't get watered down when you chill it. This is one of those episodes where I feel like I've had to make a pretty big mess to get my points across. And the service industry professional in me would feel just a little bit better if I did some tidying up before I sign off. Basically, if I'm throwing so much shade at barrel flavor percentage talk, what solutions am I proposing? Well, let's start with a sports analogy. And for this, I like baseball. Tasting a spirit blind is like going to a baseball game without knowing any of the players or anything about the teams. You show up, you watch the game, you enjoy yourself, and you get to see everything unfold in front of you without too many prior assumptions, basically with only your knowledge of how the game works. And maybe not even that if you're a novice. Running a spirit through a GCMS is like going to a game, reading the stat sheets of all the players, whether you know what all those stats mean or not, having both teams take the field, but as soon as everyone's in position, they cancel the game. No game gets played. You set up all the pieces and you know where everyone stands and what their stats are, but the game never actually starts. And assigning a blunt percentage to how much flavor a barrel contributes to a whiskey is like looking at a matchup, reading the Las Vegas betting odds, and confusing those for a perfect prediction of who's going to win the game. So the solution that I'll offer is, I think we should start getting more comfortable at all levels of expertise with watching the game unfold without the pressure of memorizing every player's stat sheet and without the added distraction of highly manipulated assumptions that skew our values. And if you're curious about how to do that, if you're looking for antidotes to the woes I've described in this episode, it's pretty simple. Just do the thing. Taste more and more diverse spirits. Taste them with people both more and less experienced than you are. When you have the opportunity, taste them blind so that you can form your preferences based on the liquid alone. These are the moves that allow you to understand what flavor does without needing to solve the impossible problem of what it is. And let's be honest here. I'd be absolutely crazy if I even for 1 second implied that barrels don't have a massive impact on whiskey flavor. Obviously they do. You take one look, one sniff, one taste, and it's right there. But more than picking on a little corner of whiskey discourse that annoys me, I think of this rant as one of many entry points into a larger conversation about flavor as a thing in motion, rather than a collection of food word tasting notes or a pie chart with percentages. I think that if you're overly focused on plotting flavor on a graph or measuring it in parts per million or reducing it to a handy tool that you can use to bludgeon the nuance out of every spirit you taste, then you miss out on the wilder, more intense experience of flavor as an emergent phenomenon, one that rewrites your neural architecture and colors your memories every time you taste something dazzlingly new or comfortingly familiar. Remember, there's no quiz after you taste something. I think that's actually what people get wrong about flavor professionals, people in this industry who make and taste and evaluate. They think every day for us is like taking a sommelier exam. No. That's not the case for us, and it's certainly not the case for you. You're here to enjoy and pay attention and take it all in, and I'm very confident that you can manage to do that without buying some nonsensical infomercial tchotchke invented to solve a problem that doesn't actually exist. So next time you're on a distillery tour or reading a whiskey review and somebody trots out the old barrel math to enlighten you, I hope that you'll have the presence of mind to say, I like the whiskey, but your whiskey math is bullshit. If you've made it all the way through, dear listener, thank you for tolerating my quixotic tilt at this very inoffensive-seeming windmill. I promise it was very much a big ferocious giant to me, and I'm glad I was able to save us all from it before it was too late. So I will bid you farewell in my customary nightly fashion by inviting you, as always, to drink responsibly and experiment boldly. Come, Sancho. I have heard there's a celebrity tequila dragon tormenting the good people in the next village. Hey everybody, thanks for listening. If you enjoyed this episode, there's a couple things you can do to help the show. One would be to rate and review this program anywhere you enjoy listening to podcasts, especially on Apple Podcasts and Spotify. The more ratings and reviews we have, the easier it will be for other like-minded flavor nerds to enjoy the content that I produce. You can also follow the Modern Bar Cart YouTube channel, where I post video clips from the podcast and beyond, and you can join our growing Discord community, which is where our listeners submit questions for upcoming guests and chat about all kinds of fun spirits and cocktail shenanigans. It's also where I share fun perks and discounts that are too exclusive to blast out on the airwaves. To join our community Discord server or get in touch with me for any other reason, all you need to do is drop me a line by emailing podcast@modernbarcart.com. This episode may be over, but for you, the mixological fun and boozy adventures are just beginning. So remember, drink responsibly and experiment boldly. This episode was made possible with editing and sound design by Samantha Reed and a little bit of crazy ranting by yours truly. This has been a Direct Fire Studios production, copyright 2026.